Well, good morning or good afternoon, everybody. At the time of recording this is a rainy morning, and it's a great time to start our solutions unit. This is chapter 15.1 for some terms, and then the rest of it's going to be in chapter 16. So, a new term here. We've just finished the mole unit, and I guess the first thing we're going to talk about is when we're talking about solutions, we're going to be talking about the concentration of solutions. So the first one underneath here, I guess, is going to be, actually, let's make this a number one. So I guess I'll call this concentrations of solutions. And when we're working with solutions, we've got kind of two things going on. You see over there. Okay, we've got the liquid part of a solution. And the technical term for this is solvent. Now this is part of your vocabulary homework tonight. Solvent is the liquid part. And then as we add stuff into it, let's say we're going to pour some salt. This is supposed to be a salt shaker here, salt. And as we pour some salt into the liquid, the dissolved solids that are in there, that's called solute. So that's the dissolved solids. And that's your homework vocabulary terms, is just, that's part of the terms there. So the first thing I'm going to have you work on is something called molarity. So under number one here, molarity. And this is equal to the number of moles of solute that you have dissolved in a solution divided by how many liters. So that's moles of solute, solute over solvent. I'm just going to leave it there. So moles per liter. So when we go to work on these, for example, let's do a quick example here. Example, given. Now I'm reading this problem. What is the molarity of, okay, so given, find. So we are looking for molarity, which is moles divided by liter, okay? So we don't have a lot of calculations in this. Well, there's some calculations, but they're not as extensive as the last one. Let's see, we need to find the molarity of a solution that is 20, now here's the given, 25 grams of salt. Now that's going to be NaCl, table salt. So we have 25 grams of salt, and we have that in 100 milliliters of solution. So that's what we're working on there. So to go through, first thing you have to do is, in these problems, since we're given grams, you got to convert that into moles. So we're going to say 25 grams NaCl. That's our given. We'll put that over 1. The first step is we got to find the number of moles. And let's see. Well, since we want to get rid of the grams and end it in moles, let's see. I want to say 58. Sodium is 23, and chlorine is 35, and that rounds to, 58 grams of NaCl in 1 mole of NaCl. So 25 divided by 58 is going to be, well, that's going to be incredibly close. Get your calculators out. Yep, calculators. Again, 25 divided by 58 is going to be close to half. Let's see, 25 divided 58 equals 0.43 moles of NaCl. So now we've got the first part here, because remember, we need to find moles per liter. So now I'm just going to come over here and rewrite this. Capital M this time is moles divided by liters. Let's substitute in the moles. 0.43 mole NaCl divided by, now we've got 100 milliliters. 100 milliliters, we need to change that into liters by dividing it by 1,000. So the nice thing is, milliliters, when you change it to liters, you just move this over 3 decimal places, and that's going to become 0.1 liter. So now, 0.43 divided by 0.1 liters, now you got to make sure you get it into liters, is going to equal a molarity of 4.3 moles per liter. So that's how we do that, and I'll have you work on the practice sheet that's in your packet that you picked up. So there you go. It's a way to measure concentration, how much solute is dissolved into the solvent. And in this one, we ended up, there's 4.3 moles, NaCl in every liter of our solution. So there you go. Have fun.